Okay, these are some more of the Are You Ready for Calculus? This is number 3, and we wanted to simplify these. We just wanted to make sure that there wasn't a fraction in the variable form, so we wanted to make sure that a and b were up in the top. So basically we just started with 2a squared to the third over b, so I just raised each of these factors to the third power. So 2 cubed is 8, and we just multiply exponents. 2 times 3 is 6, and then we put the b in the top, and we get b to the minus 1, so that was pretty straightforward. Okay, this b, we had a radical, so we changed it to exponential form. Pardon me, there we go. And that was 9a, b to the third. Hopefully you have these copied off, and you can be looking at these as we go through these. This is a little bit smaller. This was originally done in a notebook, so just copy them out to save a little bit of time. And then the radical is the 1/2 power, so I'll rewrite this as 9a, b to the third to the 1/2. And then I raise each of these to the 1/2. So 9 to the 1/2, a to the 1/2, and 3 to the b to the 3 times 1/2, which is 3/2. And then I just take the square root of 9. And then these are in the form that they want. And you can always check your answers. They're algebraically equivalent. It's just making sure that you get your answer in the same form. Okay, here we had a complex fraction, and for some reason I just did this the traditional way rather than multiplying the top and the bottom by the LCD. So first of all, I made this one fraction just by multiplying numerator times numerator. So I get 2a over b, 3 over a. And then, like I said, I did this the more traditional way where we think of this as a division sign. And we can write this as the top fraction divided by the bottom fraction, invert and multiply. And then we have 2a squared over 3b. And then the number, the coefficient could be a fraction, it was just a number, but then we wanted to make sure that the a and the b were in the numerator, so we just put the b up in the top, so that's 1 becomes minus 1, or negative 1. Okay, and then the next one, letter D. First of all, letter D, I could see that I have common factor of a in the top, a common factor of b in the bottom, so I factor, and then I notice I have b minus 1 in the numerator and denominator. So I can just cancel those common factors, and then I just put the b in the top, so it goes from 1 to negative 1, and there we go. So hopefully these were easy for you, I hope. Letter E. Again, letter E, what we want to do is just change this to radical form. That's all I did in that step, and then I move this to the top to make that 1, and move this to the top to make that a negative 1/2. Then we just add the exponents when we have same base, so negative 1 and negative 1/2 is negative 3/2, and the b's in the top. All right. And again, you can always pause these and take a look at them if you're having any problems. Okay, letter F. So this is what we start with, and then the first thing I do is I just remember when we raise powers, you just follow the same order of operations, powers first and multiplication, so I'll raise powers. So I multiply. When I'm raising bases to powers, I multiply the exponents, so that's 4/3, a to the 4/3 over, and then 2 times 1/2 is 1, and this stays the same. So that's b to the 3/2 over a to the 1/2. And then we want to put everything in the top to get our answers in the same form that the book or the assignment request. So a to the 4/3, a to the negative 1/2, b to the 3/2, b to the minus 1. Now in order to add these fractions or subtract, I have to have a common denominator. That common denominator was 6. So I made this 8/6 and I made this 3/6, and 8/6 minus 3/6 is 5/6. And then 3/2 minus 1, which is 2/2, is just 1/2. So that's the form they wanted. And that was that. Okay, then we have some logarithms and exponential equations on the next section here, or number 4, I should say. So first of all, number 4, we start off with this equation. So I should do it like this so you can see what we're doing here. Now whenever we have a variable in the exponent, that's what we call an exponential equation. And there's several ways to do these by using logarithms, but sometimes we can do them without using logarithms if we can get the same base. And I know that this looks like 5 to the second power, so I can quite easily make these to be the same base. Now, this is basically, I kind of drew a sketch of an exponential, the general exponential equation, ay equals a to the x, and you can see how this is a one-to-one function. That means for each element in the domain, there's exactly one element in the range. The range is the value. So basically, we're saying if this is the same as this, in other words, if the range is the same, then the domain's got to be the same element. So basically, we're saying that if the left side equals the right side, then the exponents have got to be the same. If we have the same base and the left side equals the right side, then the exponents have got to be the same because it's a one-to-one function. So now we know that the bases are the same, so the exponents are the same, so x plus 1 equals 2, and then it's very easy from that. X equals 1. And you can always check it. 1 plus 1 is 2, 5 squared is 25. Okay, let's take a look at letter B. Same idea, we have an exponential equation over here. So I try to get the same base, and I could quite easily make this base 3 just by putting this 3 on top. And now my left side equals the right side. That's like saying my vertical position is the same. So the bases are the same. The exponents have got to be the same. So negative 1 equals 2x plus 3. And then I just subtract 2 from both sides and divide, and x equals negative 3 halves. So again, this is really good to use this one-to-one characteristic of these functions. All right? Okay, over here, next one. And then this is a basic logarithmic equation. Remember, logarithm is just an exponent. It's defined like that. And basically our base is 2. Since this is an exponent, that's also equal to that. So that's an exponent. So my base is 2, my exponent is 3, and this is the answer. In other words, this is the exponent, then when I raise 2 to it, I get x. So 2 to the third equals x. And what's 2 to the third? 8. So no problem. Okay, and the last part. Now we have kind of a more complicated logarithmic equation. And what we try to do is get one log on the left and one log on the right. And kind of like exponents, see, this is the logarithmic function. It's a general logarithmic function. And that's also one-to-one. So for each point, if I only have one vertical position, I've got one corresponding horizontal position. Because it's a one-to-one function. So I use my properties of exponents. And remember, one of the properties was I can move this exponent from here to the front or vice versa. So I'm going to go backwards, and I'm going to put this 2 up on the 4 as a squared, and then this 4 as a fourth power of the 5. Now my motivation is this, because that I want to get one log on the left and one log on the right. Okay, so there we go. Now remember, one of the other properties was the log of a quotient is the difference of the logs, or vice versa, the difference of the logs is the log of a quotient. So I can combine these as the log to the base 3 of 4 squared over log to the base 3 of 5 to the 4th, as long as my bases are the same, and they're all base 3 in this problem. Now I've got one log on the left and one log on the right. Remember, logarithms are also one-to-one. So if the left equals the right, then these, sometimes called the arguments, are the same. So I can say x squared equals 4 squared over 5 to the 4th. And then I take the square root of both sides. And I get x equals plus or minus the square root of 4 squared over 5 to the 4th. The square root of 4 squared is 4. The square root of 5 to the 4th is 5 squared, which is 25. And there's your answer. Okay. Now, if any of these aren't really clear, just drop me an email, richard_martinez@chino.k12.ca.us, and I'll try to clarify it in a different video. Okay. Hopefully this is all straightforward.